One common way of describing the accuracy of an estimate of a population parameter is by reporting a range called a confidence interval around the estimate. For example, starting with some data, which is assumed to be a sample drawn from some large population, an estimate for the mean of that population is the mean of the sample. In the Wolfram language, a confidence interval for that estimate can be computed using the mean CI function, which is defined in the hypothesis testing package. These inputs load the package and compute the confidence interval. CI in the name mean CI stands for confidence interval. The result from the mean CI function is a list giving the endpoints of the interval. Here's a number line plot of those results showing the values in the sample, the confidence interval, and the sample mean shown as a dot in the middle of the interval. Two important questions to be answered about this or any other confidence interval are what exactly does that interval show and when is it valid? The first question will be addressed here, and the second question, which is more involved, will be addressed in the next few sections. An important number that goes into computing a confidence interval is a percentage called the confidence level. The confidence level used here is specified by the confidence level option of the mean CI function. The default confidence level is 0.95, which means that there is a 95% chance that the process of drawing a sample and computing a confidence interval will give an interval that includes the population parameter. To help explain more clearly what that statement means, note that each random sample from the population will give a different sample mean and a different confidence interval. For example, here is another random sample from the same population, which gives a different confidence interval, and here is a third random sample still from the same population and a third confidence interval. And here's a number line plot showing all three confidence intervals. This process can be repeated to compute more intervals. Here's a plot of 20 confidence intervals computed using 20 different samples from the same population. With a confidence level of 0.95 or 95%, it is expected that, on average, 95% of the confidence intervals will include the population parameter, and that is what has happened in this example. 19 of the 20 intervals, or 95%, do include the population mean, and one of the intervals does not include the population mean. Increasing the confidence level causes the confidence intervals to get wider. With a confidence level of 99.99%, for example, all of the confidence intervals in this plot easily include the population mean, but the confidence intervals needed to make that happen are more than twice as wide. Decreasing the confidence level causes the confidence intervals to get smaller and results in more intervals that do not include the population mean. With a confidence level set to 50%, for example, the confidence intervals are much smaller, but many of the intervals do not include the population mean. On average, with the confidence level set to 50%, only 50% of the confidence intervals will include the population mean. The exact choice of confidence level is usually not critical. 95% is a common choice, but in most applications, any choice that serves the purpose of providing a rough idea of the accuracy of the estimate is good enough. For a confidence interval based on one sample, a precise mathematical description of the confidence level and the confidence interval is that the confidence level gives the probability that the process of drawing a sample and computing a confidence interval will give an interval that includes the population parameter. Some common alternative descriptions that are basically accurate and then might be more intuitive or easier to remember include the confidence level gives the success rate of the process, or the confidence level specifies how confident we can be that the interval includes the population parameter, or the confidence interval gives a range of plausible values for the population parameter. A tempting but incorrect description is that the confidence level gives the probability that a particular confidence interval includes the population parameter. The problem with this description is that a particular confidence level either includes the population parameter or it doesn't, so it isn't meaningful to describe the chance or the probability of that happening. Words like chance and probability are important words in statistics. Chance and probability are used to describe outcomes of random processes. It is meaningful to say, for example, that a process of computing a confidence interval has some probability of giving a certain result, but an individual confidence interval is not a random process, it's just an interval. The next few sections will explore the more mathematical topics of how a confidence interval is calculated and the assumptions that go into that calculation.